Good day, I'm Dr. T and welcome to my office. So in previous videos I had talked about jumping in and teaching courses. And in the last video in this series I had talked about lecturing. The kind of backstop, the traditional way of teaching, especially in a higher ed course. Now, lecturing is what we quite often refer to as passive learning. The idea is the student is basically sitting and listening. Hopefully they're taking notes. Hopefully they're active listeners. They're thinking about what you're talking about, asking questions, etc. But the truth is that most of them are just listening. Hopefully they are actually listening and not completely zoned out, but they're probably not some high-level active listening at this point. And the other truth is, the more you think about something, the more you engage with the concepts, the more you learn them. Simply hearing them in the background while you're thinking about something else is a terrible way of learning. And even just simply sitting and listening to something is not the most effective way to learn something. Instead, you need to get in and get hands-on with something, whether that be figuratively or literally. This approach of encouraging or creating a learning environment for students to actively engage with the material and thus learn by it is known as active learning. And there are quite a few different approaches. Some that I use a lot, others that I have never engaged with myself because for my content they don't particularly make sense or I've just not heard of them. The one I'd like to talk about in this video is known as guided inquiry learning. And this is the one I use a lot in classes that have a lot of kind of math-based approach. So general chemistry, the first part of survey chemistry, the classes that we're going to be looking at mathematical laws because we can easily discover why those laws are there. Or sometimes maybe not so easily, but we can still discover why those laws are there. For content that is, to be honest, somewhat arbitrary, like the names of the 20 common amino acids, they're called that because someone decided to call that. Sometimes there's patterns there, and sometimes there's not. So in that case, guided inquiry learning doesn't work that well because the why is someone said so. Okay, so what is this guided inquiry learning that I'm talking about? The goal here in guided inquiry learning is you give the students a set of information, some kind of foundation to query. I'll call this the model. And this model might be, for instance, a series of balloons, each with the pressure, temperature, volume, and moles of gas within this. And this particular activity is on my website, linked below. From these balloons, then the students are asked a series of questions. First series of questions are going to be get them to look at the balloons. As they're looking at the balloons, then they're going to be prompted about a certain relationship. For instance, what is the relationship between volume and pressure, all things else being the same? So then the students presumably should be looking for two balloons in which the volume and pressure are different, but every other property of the balloons are the same. And then they find that there's an inverse relationship between volume and pressure. The goal here is to go through what's known as a learning cycle. To begin with, you ask the students to engage with the material, to observe what's going on. Find the patterns. Humans are great at pattern finding, and thus we are utilizing this in order to learn. Look for the patterns. Once the students have seen the patterns, then at this point, we ask them to start using the patterns and tell them what they're called. The goal here is you don't actually want to say, Boyle's law is this. You want the students to learn what this is, and then you say, the thing you have just learned is known as Boyle's law. As humans, we store ideas and stick names on them. We don't stick ideas onto names. We're not like a computer. Then, once they have developed the concept, then you have them use the concept a little bit, get a little practice under their belt, and then depending on the objective of your particular activity, if it was a fairly simple concept, move on to the next learning cycle. Discover a new pattern, learn that concept, use that a bit, and move. Alternatively, if it's a much more complicated pattern, then instead of one or two questions to discover the pattern, then it might take several questions to slowly develop the pattern. So that leads them into discovery of the pattern, then they lead into being able to utilize that pattern to their advantage, and it may be a longer learning cycle. The goal here, though, is We're guiding them not by telling them what they need to know, but by leading them there with a series of guided questions. Now, there is an alternative form of unguided inquiry learning, in which case your students are given a model and they're told to figure it out themselves. While sometimes this actually works, and this is in many respects what we do when we have a problem that we have to solve, and hello Google, let's try and figure this out. To be honest, for most students, this is not a good approach, and I do not recommend unguided inquiry learning. Students need structure. That's what we are here for. And by creating the guided part of the inquiry learning, we are able to help the students discover the content. Now, as stated in the lecture video, I do strongly encourage you to have a lecture as a backup, just in case the guided inquiry learning did not work. Because that does happen. Some students will just not get it and need to be told directly what the content is. So, lecture as a backstop, but you will notice that if you lecture fairly efficiently, you've got plenty of time, even without doing a hybrid or flipped strategy course, to do other learning activities, such as guided inquiry learning, which do work better when reasonably well implemented. So with that said, have a wonderful day.